Please take down this question. The temperature is 55. So what is that? See the statement, first statement of the problem. So on a typical day, this is the temperature of that body. So what is this?
T.
This is the initial temperature, right? Ti. And now suddenly the surface is exposed to the water here. So what is the effect of that? Cooling. Right? It's cold water. So the surface temperature is now lowered to 35. We don't know what is happening under the surface. We are talking about only surface, right? See, this is also a case where typically during summer season we try to wet the top surface of the slab or your roof with water, so that immediately the surface gets cooled. People are doing this for two reasons: one, to sleep there on the top of the building, and the second maybe to reduce the heat transfer to the building. So though the surface is quickly cooled, right, again if you observe, slowly again it starts generating the heat from within. Okay. So therefore that effect is at that instant of time, quickly there will be change in the surface condition. That need not remain permanent. But here the condition is that surface is lower to that. Then because of that, what's the effect? How is the heat being transferred within the body? That is the effect. So now, how long will it take to cool the concrete? Now suppose you are constantly pouring this. You haven't stopped pouring the water. So therefore the surface is now fixed at this temperature. You are not allowing it to deviate. You are continuously wetting the surface with water. You have not just poured it and then put it off. It's continuously on. So under that condition, naturally the body gets cooled slowly. That cooling effect penetrates gradually deep inside. So the question here is, at a depth of say 5 centimeters, how much time will it take for the body to come to this temperature? That is the question. So this is the given data. Ti, Ts. Now to get this value of temperature, what is the time? And depth is x, and the properties are given directly. And now the formula. Now the moment you see this problem, you should understand, right? This pertains to semi-infinite body, because the surface is suddenly, by seeing the description of the problem, you should understand this, right? So now it is asked at a depth of this. Now if it is the previous case, question will not be like this, because the entire body is at the same temperature. There is no resistance here. The x parameter simply doesn't appear there. So since x appears here, that is one way of you connecting to this concept. So now, with this data, please look here, you can note down later. This is the temperature distribution equation that we have seen, right? Now, substitute the values. 0.5 is equal to error function of x by 2 root alpha t. Now, this Gaussian error function values tables are available in your data. So for a value of error function of something is equal to 0.5, this something should have some value, right? And now that you can get it from Gaussian error function tables. Please look at this. Any value x by 2 root alpha t is now our variable, and error function of it is this, right? So likewise, you go here. See now, the error function of this variable in our problem is 0.5. This is equal to 0.5. Isn't it? Then what is this value? The value of this parameter inside the brackets?
0.5.
That means if x value is 0.48, error function of x is simply, I am assuming this entire term as x. So if x value is 0.48, error function of x is 0.5 approximately. Now if error function of something is 0.5, then error function of x is this is given. So therefore the x value must be 0.48, right? So this is the table that we have to use in order to find this variable. Okay. So now here, so this is 0.5, then this x value is approximately 0.48, and you know alpha and t, sorry, x and alpha, and only unknown is p. You can find out time value.